Good afternoon. My name is Dave Eckroat. I'm the director for the IDEA StatiCa US office. It's 12 noon here on the East Coast, so we're going to go ahead and get started. Today's topic for our webinar is some modeling tips and tricks. Hopefully this will be useful for everyone. You might learn, hopefully you're going to learn something today. As usual, I have both Andrea and Jan with me. Again, as usual, Andrea will be doing a lot of the presentation today. Thank you for joining us. And with that, Andrea, can you move the slide? I just wanted to kind of mention that we are kind of getting into a good cadence with the webinars as far as having them on Wednesdays at noon Eastern. So we have a couple of upcoming webinars. There's going to be one in about 4 weeks that's going to be focused on bolts and welds within IDEA StatiCa. In September, we'll be doing a webinar on interoperability, kind of how IDEA StatiCa works with other pieces of software that you're using, particularly for analysis or detailing. And then in October, pretty exciting in that we're going to be doing the first of our verification webinars with the University of Tennessee. So as many of you probably know, we've been working with several universities here in the US to just verify the results that you're getting from IDEA StatiCa and meeting the AISC code. So that'll be the first one of those. We're going to plan on breaking them up a couple of months at a time so you can kind of hear from the actual people that have done some verification on the software. Again, as usual, you can use the question screen or tab to submit any questions. We will try to answer those directly during the webinar and then also follow up afterwards or at the end of the webinar to make sure everyone kind of hears the answers. So with that, I am going to turn it over to Andrea.
Great. Okay. So let's start because I have many information to share with you guys, right? So, okay. So let's start with the next, the tips and tricks. We have 15 tips to share with you guys. So let's start with the first one. So the use of offsets should be avoided as they can lead to eccentricities, which can produce an extra moment once loads are applied. Okay, so for these tips, I will use some examples that I have prepared for you, and some of them I will work on it. Okay, so this is the first example. This is a joint that has any connection here. Okay, so when you're seeing just the geometry, you can see that the elements are connected through their centroid, okay? So that can be seen graphically here in the solid view and also the transparent view, okay? So when you click on the member, you will see that you have this option to add an offset. And some of you, some users, what they do is just to move the member to align it where you want it. For example, in this case, the B member, move it down like 6 inches down here in the C direction, right? To align with the top flange. So you say like, okay, I can start adding operations to add connections here. But the thing that you're missing here is that if you go to the wireframe view, you will see that we have this working point, and this is where all the members that you are adding are connected, right? So you are moving also the member down over here 6 inches. So what that will lead to that eccentricity of 6 inches, and then if you add a load, let's say an actual load, then you have an eccentricity, a load, and then a moment is created here, right? So that wasn't planned. So sometimes you also move C member, for example, here -6. So if you go now to wireframe view, you will see that this C member is also moved. So again, another another moment can be generated here, right? So if you see here, where is the node, it's all moved. So then that takes me to the next tip, right? So we highly recommend to use operations instead of offsets, right? To avoid these errors or these extra moments. So some operations like shear tap, cleat, and plate include the cut operation by default, but some of them you have to add a new operation to add that cut, okay? So let me show you here. Instead of using this offset option here, let me delete this, okay? For example, in this case, I'll move this C member using the cut operation. So if you're seeing here this screen, this is new. This is in the latest release, so you can see the new screen for operations. Those are the same, but this is just a fresh look, right? So if you click here and cut, and that cut is applied to member C, cutting method bounding box is okay, but the trick here is to use the farther option. So that will be cut until the farther side of B member, in this case the flange. And then you can add an offset, let's say half of an inch there. So that is half of an inch above this flange, right? Then you can start applying operations. In this case, for example, fin plate. Let me apply that to member C and connected to member B connected to member C. And as I mentioned, that cut is included within this operation. So if you now go to wireframe view, you will see that these members are connected through their centroid, and they are like graphically okay, right? So in that case, you are not confusing adding a load with an eccentricity. So we recommend to use operations instead of offsets when possible, okay? So let me go back to my screen here. So the third tip is the model type. So this is a frequent question. Which model type should we use for selected members? So let me show you where you can select the model type. So the model type, if you click in one member, you will see that at the end of this screen. So you can select from here from 4 options, all right? And every member have the option to have different model types, okay? So the default is the first one. I will show you that on my presentation, okay? So the first one is this long name that has N, BY, BC, MX, MY, and MC. This means what forces you can apply to that member. And also in that model type, you're telling the software the boundary condition for that member. In this case, this option is full fixed, okay? So then the next two, we have forces in, axial force, BC, that it's shear force in the vertical direction, as you can see the sign, and MY. So you can apply a moment around local y-axis. And the boundary condition in this case is that it is fixed in the strong axis. So we have the third option that it's N, BY, MC. So you can see here you can add an axial force as well, BY, that it's like a lateral force, and a moment around C local axis of the member. Okay, the boundary condition in this case is that this member is fixed in the weak axis. Then the fourth option here is that you can apply an axial force, BY and BC, so shear forces in C direction, C local direction, and in C and Y, right? And the boundary condition is that this member is pinned. So this option is recommended for bracing elements when you have it in your model, right? And this boundary condition means that this member cannot rotate. Okay, so that's the appropriate for bracing elements. So, okay, the next tip is how to use a DXF to create a plate geometry. Okay, so for that, I'm going to use this example from AISC Design Guide number 29. Here I am focused just in the modeling, right? I will not go until the analysis and design. Maybe in the future I can create another webinar for that, but today I am going to focus just in the design of this. So let's imagine I did the design of this Gusset plate in DXF. So I did that in CAD software. I create that design using lines. That is important to use lines, and the design needs to be close. Okay, so in that case, we can read that geometry, and that needs to be saved in DXF file, well, extension, right? And then you can use it in IDEA. So let me bring the model here. Okay, so this is the model that I am going to show you. This case, I have already modeled this part of the connection. Also, this is welded to the column. This beam to column is welded there. And I have the member, right, that I'm going to connect using that gusset plate. For then, I'll add an operation. I'll use the stiffening plate operation, right? And by default, the shape is rectangular, so you can see the plate here. So if you put transparent view and you rotate this model, you will see the plate over there, right? And then you can give dimensions. But for using the DXF, you need to select polygon, and then you will see here the DXF option. Okay, so you click there. And here you will need to look for the DXF drawing. You open that, and this screen will be open. So you can have more designs there because you need to select which design you want to transfer to IDEA StatiCa. The first step is to change the units you use in that drawing. So I use inches there, and I am going to zoom here in the design I want to use. I select one of the lines, and I can keep selecting using the control key, or just selecting one line and clicking on consecutive. Okay, so that will click in everything here, in all the lines in the design, and then you click outline. So that will give you a preview of that design that you did, right? And then here you can verify that units are okay, right? Because you know the drawing. So then you click OK, and then that plate is over here. Well, it is located in the origin, that it's the working point again. So you can change that and change from a member or from a plate. I'll use joint, and I'll rotate this plate like 90 degrees in the X direction. So now it is rotated as I want. Then I can use the coordinates to locate that plate. So that will be 28 and a half in the X direction, okay? And then in the Z direction, that will be 1 foot and 11 inches here, okay? So now that, well, this location, I want to share also a tip about that. So let me go back to my presentation just to show you what is the next tip, okay? So the fifth tip is start with larger than required plate size and use plate cut operation to align with the required members. In this case, you can start the plate like from scratch with the rectangular dimensions, and that will be longer or wider, right? But in this case, I am recommending to just locate a little bit inside of that column. For example, here you can see in the transparent view that this is a little bit inside of the column. So instead of guessing how many inches you want to, you need to decrease or increase to have that just in the limit of the column. Instead of doing that, you can just use this operation that it's cut off plate, right? So that cut off plate will cut that plate by this C member. You can see it here, right? So this is cut off plate, and then you select the modify item. So here you will see that I am selecting a plate right? And this was assigned automatically to SP1. And here is the option plate, right? Because I select that. But sometimes you will have a more complex model with more operation and more plates, right? So you don't know which plate is going to be, well, you need to apply that. So that takes me to the next tip, okay? So you can get immediate help when you hover the mouse over the plates or inputs. So let me show you that here in the software. So if you hover the mouse over this plate, you will see the name of the plate, the material, and the thickness of it. So if you look here in the lower left side of the screen, so you can see that it's called SP1 material A992 and thickness is 3/8, right? So you know the name of this plate when you have more complex model. Also, if you hover the mouse over this top flange of the beam, you will see that the name, well, the name of that plate and in which member is. For example, this is in member B, and the name of this plate is top flange 1, right? So this is very useful when, for example, in this case, I have this plate, and this is SPL1A, and this, the one that it's in the rear side, is SPL1B. So sometimes it's confusing, so you can do that and hover the mouse and know what is the name of that plate to use it in another operation maybe, right? Okay, so the same with inputs. So if you hover the mouse over these inputs, you will know what you're putting there, right? Or what information is asking you. So, okay, I'll copy also this cut for the lower part of this gusset plate, and that will be SP1 cut by SM1. Okay, so I select this, SM1. So if you go now to solid view, you will see here the weld, right? And it is exactly cutted where you want it, instead of guessing where to put that. All right, so then the next tip is, let me show you here, is when you're using a gusset operation. So when using this gusset plate operation, the operation itself can create a new plate. But there is a case when you have already modeled the plate, as in this case. So you want to connect that plate with the bracing element, right? So let me go back to this model, and here we have the plate, and here we have the bracing element. So I go and select operation, and I select gusset operation. And then if you click on transparent view, you will see that there is a new plate over here, because this is gusset plate operation assigned to one member, in this case B member. I want to assign it to member M3, okay? And here you will see the connected to new plate. So the existing plate is the option that I wanted to show you now. So in this case, the existing plate is SP1. So I select SP1, and this is related to member C. So that's okay. So then you can add a gap between this start of the member C, because that's the relationship we have here. Start from the member C and the distance you want this bracing member. So for example, 12 inches here, so you get that distance. All right. And then if you go to solid view, you will see that you have the connection there and you have the weld over there. All right. So that is the 7th tip. Gusset plate operation using an existing plate. Okay. So the next one is using plate, well, creating a new plate as a doubler in another plate or member. Okay. So this tip is useful when you want to create, for example, in this case, you want to connect the gusset plate to the column using a shear tab, okay? So let me go back to the model now here. So I want to do a case connecting this gusset plate to this column using a shear tab. So I'll copy this connection to create a new option here. So you can go to the new connection over here in this drop-down menu, and I am working in a new file with the same operations. I'll delete the cut of this plate with the column, okay? And I'll add a new operation that it's going to be a stiffening plate. And I will change the origin of that stiffening plate. So that will be, the origin will be a plate, and the plate will be SP1 again. And here is where the Doubler option is type of plate. So type Doubler, okay? So you will see here the plate that it's located or it starts from the face of the related plate that it's in this case SP1. And also it has a weld. You can delete that weld because that shear tab I will connect it with bolts, right? So to turn off that that weld that you can see there around the stiffening plate, you can click over here and say no weld, right? I don't want any weld there. And then you can use the X and Y position to move that plate. And I'll use the same tip, like locating that like inside this column, right? So okay, let's give the dimensions for that shear tab that I'm going to create here. So that's going to be 13, okay, and 14 here, okay. So you can see here this this plate, and I'll move that -12 and adding that 8 inches. So now you can see I am locating this inside this column to use now the cut of plate to connect this gusset plate, sorry, that shear tab that I am trying to model over here. Let me go back and put the solid view, and then you will see in the solid view how that a plate is starting from this gusset plate, right? So if you increase the thickness of this plate, that will not overlap with the other plate because it is starting from the face. So that's the good thing of using the stiffening plate as a doubler, okay? Also, I didn't tell you this, but if you go back to the stiffening plate that was created with the DXF, you can increase the thickness. You can control the thickness with this operation. So see, it is the same. If you increase the thickness of this SP1, that will be also move with the doubler plate, all right? So then I use this operation, cut off plate again, using SP2, right? So you know the name of it, hovering the mouse and seeing the lower left corner of the screen, so you can see there SP2. So now that plate is connected. Now I'll use a bolt operation to connect these two elements. So that also takes me to the next tips. I have some tips for the bolt operation. So you can use that bolt operation. Let me go back to the model here. So you can use the bolt operation to connect two items in the model, right? So that is like a operation like a standalone. Some of the operations include those bolts, but there are some times that like this one where you want to connect two items. So I'll use this one. And then in the bolt operation, you will need to tell how many plies or, well, plates in this case you want to connect. In this case, just two elements you want to connect, right? And in this case, the first one will be the reference to locate the bolts, right? So if I select SP2 and then this is SP1, Okay, so the start of this plate will be the reference in the lateral and vertical direction when I am locating this using like this coordinate. So let me put this. So the start of that plate from here will be the reference. So let's use 2 inches there from this start, and the vertical one, let's say it's going to be 11 minus 11 here. And then you can put another bolt, inputting a space, then the distance between the last one, then you have the next bolt. Okay, also you can add an asterisk there, and let's say you want to put 8 bolts with the same distance, so it is 3 inches by 7 bolts, so you get the bolts over there. Okay, another example that I have, this is already done. Let me just bring this to show you those tips in the bolt operation. So for example, in this case, a filler plate as well was used. You can see this plate here. And that one was a doubler as well. And starting from a plate of a member, so you also don't have to guess the thickness. You need to fill between these 2 elements, because here this bracing element was shorter than the column, right? So I use that filler plate, and I just graphically, with this view, increase the thickness of this. Okay. So so here, when I go to the grid operation, the bolt grid operation, you will see that here I am connecting 3 elements, right? So M3, that it's the top flange, SP2, that it's the filler plate, and SP1, that it's the gusset plate for this example, right? And the first one was, it is the reference when locating the bolts. So when you are connecting a bracing element that has an angle, or like a diagonal, I recommend to always use the bracing element, so that will be the reference along the longitudinal axis. So it is easier for you to locate those bolts. All right. Okay, so now let's go to the next one. Okay. Using plate editor. So this is very useful when you're creating from scratch stiffening plate, just as I did here, right? In this case, if I put the transparent view, imagine I want to add a gap between the column and the gusset plate. So if you click in this stiffening plate operation, we always have this editor option here at the top where my mouse is. So I click there, and then you can see here that we can add sub operations to this plate, right? So maybe adding a rounding, chamfer, right? So you can do that inside this plate editor. So also, if you go to drawing, you will see all the dimensions. Let me maximize this view. So you will see the dimensions here, and if you right click, you can send this drawing to the XF again with these dimensions, right? So it's very useful. So in this case, I'll use the offset operation here to add that gap. So here you can see that the offset is already applied to all the edges. Okay. If you uncheck the whole outline, you can select which edge you want to add that offset. So I'll select the edge number 3, that it's on the bolts, just outside the bolts, and I'll add 1 inch. So if I apply this, you will see the offset over there. So I always recommend to have the plate editor like here, not too big, I mean the screen not too big, so you can see the changes in the main model. Clicking on apply, and when you're sure that it's okay, you just click OK, and that will be closed. And then you can come back to editor and modify that, right? Or adding more operations. So you can use that to add that gap. right? Okay, so let's go to the next one, the 11th tip here. Okay, so we can use the cleat operation to connect a plate to the column, right? So normally we use the cleat operation to connect member to member or beam to beam, right? But if I go back to this, I'll copy this connection, right? To do that, well, to show you that. And I'll delete the grid here and the SP2, and I'll delete the offset. It wasn't delete. Apply, okay. And then I'll put the cut over there. And that cut, I will put no weld. Why? Because I want to connect this plate using cleat operation. So we have that option if you go to operation and then you use cleat operation here, okay? So that cleat operation can be applied not just a member, as you can see here. You can select the plate option. So that plate is going to be SP1. So now you're seeing that this cleat is applied to this gusset and connected to this column. Okay. Also, you can modify the angle to use. So you can just click here in the drop-down menu. So you can use previous used angle or just adding a new dimension, clicking on the plus icon. So that's how you change that. But I'll use one of the angles that I have used before. Okay. Then you can give here the dimensions like 24. You can use cleat length because the dimensions are from center line, or you can use also top of steel. Okay. So that can be used there. And then in this case, the bolts are related to the centroid of this angle, right? So if you click here, lateral view, let me put transparent view. You go back to this cleat operation, you will see the dimensions from where are taken. Okay, so you add another one here, not here, it's in the transverse direction. So -12 maybe, and then from there -3, sorry, +1, and then let me delete the one that it's in the middle, and adding 2 inches more. Sorry about that. Then -3 here, 3 positive. And then the asterisk and adding 7 bolts over there, right? So I always recommend to like delete these coordinates and start typing the coordinates just to you learn how to add those bolts in every operation. So now if you rotate, you can see that with that operation we are connecting both angles to that gusset plate. Okay, so it is very useful. Okay, let me go now to the next one. The stiffening member operation. So a stiffening member operation helps you to add a member in the model to be part of the connection. One of the keys of using a stiffening member is that you cannot directly apply a load to it. All right. So let me show you some examples where the stiffening operation will help you. So for instance, we have here a picture or a detail of a joist end of the joist connected to this column. So they use here a WT section to connect that or to sit that joist to the column, right? So I have an example of that. And then here is a connection that it's beam to column. And for some reason, you need this element connected to that beam, because maybe it's going to be done before in the workshop, or yeah, so you just come with the beam and then connect that using a plate, right? Connecting plate over here. So let me show you here the example. So here you can see a model that is representing the, well, this element is representing the end of the joist, okay? And in the list of members, you will see that we only have the joist and the column, right? But in this case, the detail needed another angle. So instead of adding that as a member, you use the stiffening member operation. You can see this option here, and also if you go to operation, the stiffening member operation is this one, okay? So that angle was added as a stiffening member. And then you can select whatever section you need. So that is the perfect sample to show you that here an angle was needed. So we use the stiffening member operation and we give some dimensions. And then this is part of the connection, but you don't need to add a load. Why? Because it is within the operations list. So if you go now to load effects, you will see that here only the force on the joist is asked, right? You don't need to add another force for this one. Also, this WT section was used as a stiffening member, correct? And then you can, well, locate that as a stiffening plate. Like you can select the origin, you can select from where to locate that, and maybe change the X position. So it is just an operation. So let me now bring the next example. So in this case, we use this stiffening member operation to transfer the load from this beam that it's here in the beam in the members list, right? But we want to analyze this connection. So that's why we're using a stiffening member here. So this beam is, well, we apply a load in the beam, and this SM1 is transferring the load using this connection. So we wanted to analyze this. We need to model a stiffening member here, okay? And this stiffening member is using the same section as the beam, of course, to connect that, right? So this is where it's useful. So you can see here the SM1 and the beam and the connection between these two. All right. All right, so let me go back to this presentation and let's go to the next one. So the next example is a connection that we have been asked, or we see that it's very common, right, for our users. So I am using this example here that is the extended shear tab. So this is a beam connected to a column web, right? And here we have an extended shear tab connected to a stiffener. So let me open this model here to show you how to do this. Okay, let me bring this model over here. So I have this already finished, but let me just show you how to start from scratch. So here we have the model without any connection. The first operation to bring is the fin plate here, okay? And if you go to the transparent view and then you look for the lateral view, you will see that here we have the fin plate. So I'll add an a gap of 5.5 inches. So that's we are extending this shear tab with its gap, right? And the overlap is going to be 3.5 here. And then I'll use this options top and bottom. In this case, I need to use center line, okay? Because I want to add or create a longer blade here to use the stiffener and then use the cut operation to cut exactly where I want, right? So again, I am using my previous tip here. So I am creating a longer blade there. Then I am going to add a stiffener here on the column, okay? And then adding cutoff blade here. So FP1, that it's this thin plate, it's going to be cut by another plate, as you can see here. And that plate is going to be the upper one, that it's a stiffener 1D. I am seeing the name here in the lower left side of the screen, right? So that it's 1D. So now you can see the line, the yellow line, that it's the weld. So if you go to solid view, you will see the weld over there, right? And I'm going to copy this operation, and now I'm going to use the stiffener 1B. Okay, so there you go. And I use minus here because that is the part that I want to delete. So now it is exactly what I want, right? The only thing that I need to do is the notch over here in this thin plate. So you go to editor and add the notch, right? I'll show you. I'm going to show you the one that it's already finished, so you can see how it finished, right? So I add this notch over here, so I have that ready. But this example helped me to explain you that here also the forces position, it is as important as model type and the offsets, right? So if you go to any member, select any member in your model, you will see that you have the model type and also you have forces in option, right? So the first option is forces in node. In this case, how you can see where is applied at, or how you can graphically see this, you go to wireframe view and then you can go to load effects. So you will see from where is starting that shear force. In this case, it is in the node. So then if you go to B member and then you change that to bolts, you will see that that load is being applied, or the line of action is being applied exactly here in the bolts, okay? Why? IDEA StatiCa applies this shear force over here, and then it creates the moment that that shear force will create on the member, okay? So that is shear force multiplied by the length, right? So where the shear force is applied, we have 0 moments. That's why we see here the cross line, okay? And then there are some times where the forces in bolts doesn't work exactly where you want. So you go back to B member and then you use position. So you can use a distance from the node to input that force. So in this case, I have 7 inches. So if I go back to load effects, you need to select load effects to see this view, okay? And wireframe view. Wireframe view, load effect, and selecting the member, you will see the loads. In this case, the force was applied 7 inches from the node, exactly where the bolts were, okay? But if I change that, just let me show you how that changed. So now here the force is being applied just here, okay? So for these cases where just a shear connection is being used, we recommend to apply the load into the bolts because is where we want that force, all right? All right, so let's go back to my presentation and let me show you the next one. So the next tip is about lifting lugs model. So the recommended approach, let me open an example of what we have been asked before. Okay, so we have been asked like how to model lifting lugs in IDEA StatiCa, or what is the workaround to do that. So if I open this model that I have here, the recommended approach is firstly model a member to be your support member, right? So this is the bearing member or support member. So you can right click and select that as a bearing member. And you will see here the fixed ends, right? And then model a stiffening plate, use the editor to give the required shape that you need, and then add a vertical member here to then apply the load to that plate. And how you're going to transfer that load from the member to this stiffening plate? Well, you use a connecting plate operation, okay? So that will use a ball to connect that connecting plate to the stiffening plate that you create before. So if you go to editor, you will see that I use some operations to do that required shape. So then you apply the load into the member, and then if you go to the check tab, you will see the stresses on that plate, right? So that's like the recommended approach. It is important that you select this model type as NBYBC, okay? So you don't have rotations in this member, just the vertical load or the axial load, all right? Okay, so let me go back to my presentation to show you the next tip. So the next tip is about weld operations or whatever operation. It's going to be show only plates or stiffening member before it. So this phrase is kind of confusing, but let me just bring a model to show you what I'm talking about. So imagine you have this connection, right, beam to column, and then you run the analysis and you see that you need a stiffening plate here. Well, a stiffening plate for this web of the column, right? So I model already that one, but then you need to bolt this cleat to the web and then to this stiffening plate. Even if it's shown here, that doesn't mean it is connecting this stiffening plate, okay? So you need to be sure that you're connecting that. So how you can change that? So here I have the grid operation that I applied before the SP1 operation, right? This is a new operation here. So you say, okay, I'm going to just add a new item to connect, right? And I put 3 items to connect. So that is the cleat, that is the web 1 of C member, and then I need to add SP1. When I add 3 items and I select the plate, then I select the drop-down menu, you will see that you don't find anything there. But you're saying like, okay, the plate is here. Why I'm not seeing this item here? So the thing is that the order of operations matter in IDEA StatiCa, right? So you can just use plates or members that are before of this grid operation. So the new operation cannot be used in this grid operation. Why? Well, this is to keep an ordered model, okay? And not to do a mess when you have some complex connections, when you have many operations over here. So what is the workaround? So I'll suggest to copy this grid operation, turn off the first one, and this new operation, then you can select that SP1. Now it is appearing here because that is created after SP1. So use the copy of operations to move those operations later, right? So that helps a lot. And then you can delete it, right? And then copy this again and do the modifications you need. All right? Okay, so now let's go with the bonus tip. that I have for you. This is related to connection browser. I know that I have talked about this connection browser. I think we need to explain you how to use it. So let me bring this model. So for the first thing I want to talk about connection browser is that this helps you to save templates of connections, or well, save templates of your designed connections. So for example, this is a very particular model, and maybe you want to share this template with your colleagues. So what you can do is you click on publish once you are finished with this connection. So this publish option will save the template for you, and that can be saved either in the private connection design set or the company connection design set. The company one, that is the option to share it with your colleagues that are in the same license group. And then if you go to manage, you will see all the connections that you previously saved and that can be used after in another connection. Okay, obviously you need to have the same geometry, but the sizes of the members can change a little bit, and you do minor modifications, but the type, well, I mean the members needs to be in the same direction, right? You can manage again the connections that you have in that manage button over here. Okay, then the one that I wanted to show you is this. So once, let's say you have this model, but you know that you have the template for this type, well, for the connection of column, bracing, beam, and bracing. Okay, but then to call those templates, you need to click here on propose. So this will show you the connection design browser, right? But it is telling you that we don't find a template for this joint. So what you can do is use the selection option. I will click on this, and then I click on this option. Then I select the members that I want to connect. You need to press Control key and selecting the members you want to look for. So you click there, and then you click like OK over there, and then you select from your templates. So I'll select this, I apply this one, and I click OK. So as I mentioned, sometimes you need to do some minor modifications like this. Oh, sorry. Here you're seeing that this plate is overlapping this column. So you go here, and instead of column bottom flange, because this is the top flange, you just modify that, right? And the same for the next cut. So some minor modifications are needed sometimes, but then let me just finish this design with the propose button, and I'll select the same, apply, OK. And then finally, I'll use the propose button for the beam to column option. I click OK, and then I can select from here, from the IDEA StatiCa database, private or company one. And then apply, OK. And then you can see with some clicks, we finished this design with my templates that I have saved before here, right? So that's the end of all the tips that I have shared with you. John, is there any question available there? Yeah, go ahead.
Thanks a lot for the presentation. So I'll just go over the different questions that have been asked during the webinar. Keep asking questions during the next few minutes if people are interested and have some concerns or questions. So the first one was regarding the DXF import that you did towards the beginning of the webinar. The question was, when offsetting the stiffener plate, the dimensions, are they based on, or on what reference point for the plate were those dimensions based out of? And so The answer is that for a connection, the dimensions are based on the central node of the connection. But for the plates, I think it's around the centroid of that plate that you will be able to move the plate from. Then regarding tubular profiles, so how to model a tubular profile filled with concrete. We do not have composite sections at the moment, so that's not something that you can do at the moment. And also how to model partial penetration groove welds, so PJP welds, for example. And we do not have that yet in the software. There's a workaround by modeling connections or modeling welds using CJPs and checking the PJP by hand on the side. Another question, could we have a PDF of this presentation? Yes, that's going to be posted on our website in the next few days. When can we have the offset if it is not recommended? I believe that was for the plate editor. This option should always be offered to you. So there should not be any occasion where there's no offset offered for you to modify the plate geometry. Is there any option of bolt hole size for slotted holes or oversized holes? And yes, you can do. You can add slots in your holes by clicking on the plate editor or bolt editor when you're looking at a bolted connection. Andrea is going to show it right now. Towards the right in the holes, that's where you'll be able to add some vertical or horizontal slots. And for the oversized holes, it's going to be in the tab at the top of the screen that is called Material. And this is where you're going to be able to edit a bolt and also its size, its hole size. Mm-hmm. The next question, are the bolts always in bearing? And how to model a slip critical bolt? So they're not always in bearing. Andrea is showing it right now. There's two ways to, or a couple necessary things to do to make it slip critical. The first one is to change from bearing to friction, that shear force transfer that Andrea is showing right now. And also to go to the code setup and modify the, how's it called, friction coefficient and slip resistance from 0.3 to 0.5. So those two will allow you to create slip critical bolts. There was a question about changing the eccentricity in extended shear plate connections, and whether or one that user was wondering why the software was not giving him different bolt sizes and different number of bolts. The software is not going to optimize the connection for you. It's only going to check what you've modeled. So it will tell you if it doesn't work, and then it's going to be your job to make it stronger if it does not work. And so the next ones, is there a way to copy load effects from one analysis method to another one? If you copy the connection and then switch the analysis type, it will bring everything over. So you will keep those different load effects. And then the next ones, David, also, if you want to chime in and see if there's a question that you would like to have answered, feel free. So I'm going to read them now. When making a DXF, go for it.
I know, I was just going to say, I know we're getting a lot of questions about PJP welds in particular. And unfortunately, we do not have that built into the software yet. As far as being able to kind of different ways to use a PJP, it's really going to be kind of more of an engineering judgment call. I mean, we can recommend using a CJP weld and then checking the PJP on the side. This is definitely something that we're evaluating and kind of trying to figure out how to put into the software. There are just a lot of different factors depending on the load directions that we need to kind of figure out how to kind of implement that into the software itself right now. So that's something that we definitely are working on. Andrea, one question, and I have to apologize, I don't know the answer. When you're doing the DXF, is it possible to put openings or holes into the DXF that will then be brought into as you import the DXF file.
Yes. If you bring from the DXF, you need to select the outline, just the outline. But let me go here. If I select this. So let's say it has an opening here, right? That's the question, right?
Right, yeah, okay, so I see that there's an opening option. So if you had an opening inside, so you get the outline first, then you can assign the openings within that plate. Just
Yeah,
trying
you
to,
click outline and then opening. Yeah, selecting the opening over there. Yep.
there's a question about how to add new bolt specifications. I think Andrea kind of showed that already, as far as just going under materials, and then you can select a bolt assembly and copy it, and then edit it to kind of modify the hole for the bolt opening, any other of the parameters there if you choose. Let's see. There's a question, and I know we're past 1 o'clock. If some people need to drop off, feel free. We'll keep answering the questions, and that'll be part of the recording, as well as we can definitely email people with some responses if there's other questions. I see a question in the angle profile. How does the bolt center line get taken into consideration? So that's actually the bolts are ideally going to line up on basically the centroid of the angle.
Neutral axis.
Neutral axis, sorry. So you will have to adjust that to kind of have it in the middle of the leg of the angle, for instance. There's a question as far as for the lifting lug, do we have a pin option for the shackles? Unfortunately, we do not. And that's why Andrea kind of showed that option of doing the single bolt connection and then having a member kind of tied to it to apply the loading. I do know that there's some development work being done on single bolt connections. So we'll just have to see how that modifies things going forward for that. Let's see. There's a question as far as about using friction bolts and how it affects the analysis. So when you're selecting a friction bolt, you're basically designing a slip critical bolt connection. So it is going to affect the capacities of the bolt itself. And you can adjust and make sure that you're using the correct factor for whatever slip critical type of bolt you're using within the code setup. There are a couple of options within the program to be able to make sure you're designing it to the way that you intend. Let's see, a couple more questions here. So asking how to basically put a percentage of load onto a beam member. So Andre, do you want to show that, or?
Yeah, no, well, what you need to do is you add a load effect over here and you activate this loads percentage. So that will be the percentage of the capacity of that member. Okay, so yeah, you add percentage instead of values, so you will see here what you're adding. If you turn off that, you will see kips over here.
But so it does not depend on the beam span. It's not like the UDL load, like 50% UDL load. It's only based on the beam capacity, so not the length of the beam.
Correct.
And there was a question about showing the AAC unit check format and summary, and not the Eurocode. As long as you create your connection using the US codes, the report and everything will be shown using AAC and imperial units and and everything that you would be expecting to see for a US project. So no Eurocode, no metric units either.
There's a couple more questions. When exporting loads to Excel, sometimes we need to keep the name of combinations after modifying them. Is there a way to re-import them to IDEA, keeping the same combo name from Excel?
I think if the
that would be those buttons. That should keep the names. If you export it, modify it in Excel, and then import it back, I believe that should work.
Yeah, that should work, and you can see the format while creating like a test, exporting it and see the name. But I will need to do a double check on that one.
Okay.
Right.
Next one we have is, do we have AICWT profiles in IDEA StatiCa? So it's interesting in how we define WTs. Basically, you can choose your, basically the wide flange section, the W section that the T would be made from, but then it allows you to define what the stem length would be. So in order to kind of have the WT section that would be typical in the AIC manual, you just have to make sure that you have that stem length equal to what would be typically in the AIC manual.
So you come here and select a new W section, and then from there you select the height of that T section. Okay.
Correct. Could you have slip critical bolts as well as bearing bolts both modeled accurately in the same model? Yes. Yeah, you can have combination of slip critical bolts in one part of the connection, and just typical bearing bolts. And let's say in this joint that Andrea has up on the screen right now, perhaps maybe that the beam splice you just want to use bearing bolts, but you want to use subcritical bolts in the connection of the gusset to the column. Yeah, you can definitely do that. The one thing that you can't do is in a connection have two different types of subcritical bolts. I don't know why you'd want to do that, but you don't have that capability right now. Let's see. We have, can you put welds on drawings for detailers to use? Andrea, would that be in the sketch?
Yeah, that can be here, and you can right click here and create a section, and this is going to be like just like an image. Let me just increase this. But then this is going to be like a picture that you can save and use it in the manual, in the report. Sorry, I am not sure if that was the question, David.
Yeah, I think more so kind of being able to export that as a DXF. I don't know that we can do that from the sketch.
No, from here, but maybe in the report.
I think you can
the bill of
export it as a
materials. Yeah.
Yeah, if you look at that sketch, I believe you can export it as a bitmap, but I don't know that it necessarily goes out as like a DXF or anything.
Yeah, you get this, and you can export this to the XF, but let me see. No, not really. Details of weld, no. I am not sure if this sketch is, no, it's not in the XF, just these drawings that are here. Right?
Correct. there's a question as far as, can you place holes in beam webs to accommodate piping or conduit passing through the member? Similarly, can you place openings to simulate castellated beams? Yes, there's an opening operation, and that allows you to put openings anywhere within a member, a plate. You can make something Swiss cheese, and it'll still kind of check the stresses around that opening. So that's a pretty nice little feature that we have within the software. Let's see, I think we're about 10 minutes over.
A question. Oh, sorry. Yeah, just a quick question about the directionality factor increase for fillet welds. Yes, you will have that in the report when the load is coming at an angle. You will see this in the report as well.
Okay.
And regarding the K and K1 values not being modeled in IDEA StatiCa when you have stiffeners, yes, you will need to go into the plate editor and, for example, model a bevel cut for your clips. You will be able to do this in the editor of the plate and go around the K and K1 radiuses like this.
Okay, and I see one last question. I think it's more of a request that we need a report for detailers to use, so show sections and all the information. I know the bill of materials can show a lot of that. We have some other things in the works to be able to kind of help detailers and be able to bring information from IDEA into a detailing model, but I'll just kind of leave that as to pique some interest. We don't necessarily have a specific time frame, but it is something that we're looking at being able to add in the near future. So with that, we went through a whole bunch of questions. I thank everyone for sticking with us there. Sorry that we went past a little bit. Just again, Andre, can you put up the future slides or the future webinars? Again, we have we're planning on doing a webinar pretty much once a month towards the end of the month. So again, the next one will be August 31st, and that'll be focusing on bolts and welds within IDEA. So I appreciate everybody coming out, and hopefully this was very helpful and informative, and now you can be even more effective using IDEA StatiCa. So thanks again, and have a good day.
Thank you. Bye-bye.
Thank you.